This is section 4.1 part 1, and we are going to begin looking at the graph of a quadratic equation. And as always, when we look at a new type of graph, we're going to first analyze the parent function, which we've done for linear equations and absolute value equations. For linear equations, you can remember the parent function was y equals x. And for absolute value equations, the parent function was y equals the absolute value of x. Right, and so for quadratic equations, our parent function is going to have this form, which is y equals x squared. And remember, this is the most basic form of the graph for the quadratics, is y equals x squared. And what do we know is true about this type of graph? Well, we always know that the vertex for this parent function is going to lie at the point 0, 0. So once you identify your vertex when you're trying to graph a quadratic, which should always be the first thing you do, you should always first find your vertex. You're going to make a table. So I've got a table here, and notice there's a spot for 5 different points. When you're typically graphing a quadratic equation, you want to find 5 points. And your vertex should always go right in the center. So we know the x value of my vertex is 0. The y value of my vertex is 0. Alright, so I'm going to plug 0 here, 0 here. So how do we find the rest of these points? Well, you want to go in positive direction and the negative direction, so both sides of 0, and I'm going to increase by increments of 1. So I'm going to go up to positive 1, and from 0 down to negative 1. Then from 1 I'm going to go up to positive 2, and then from negative 1 I'm going to go down to negative 2. And then to find the corresponding y values, we simply plug each x value back into the equation y equals x squared and evaluate them and find our y value. So if we have x equals 1, we can plug 1 into this equation where we see y equals 1 squared. 1 squared is still 1, so y will equal 1. So when the value of x is 1, we know y is 1. What about x equals negative 1, going in the opposite direction? So we'll plug in negative 1. So we have y equals negative 1 squared. Negative 1 squared is still 1. So when x is negative 1, y is 1. And that will always be the case. Alright, whenever you have a negative, once you square it, your answer is going to become positive. So let's try x equals 2. So we have y equals 2 squared. 2 squared is 4, so we see y equals 4. So what can we assume? If x is 1 and y is 1, and x is negative 1 and y is still 1, these two numbers are the same. Can we assume that y will also be 4? And you can. So a little trick, whenever you are graphing your quadratic equation, if your x values are the same distance away from your vertex on either side, your y values will be the exact same numbers. So these numbers should always end up being the same, and these numbers should always end up being the same if we've set the problem up correctly. So now I have my 5 values, so I'm going to plot them and then draw my parabola. So I'm going to start with my vertex of 0, 0. Then I'm going to plot 1, 1, and then 2, 4. Then I plot negative 1, 1, and negative 2, 4. And I'm going to connect it. It's this U-shaped graph, which is called a parabola. And there's a couple of things we want to look at on this U-shaped graph here. Alright, first things first, with your parent function will always have these points. So rather than when you have to graph your parent function doing this process over and over again, if you can just memorize these points, it might be slightly faster for you. Secondly, with each parent function, there's an imaginary line, a vertical line that passes right through the vertex, and we can represent it with a dashed line. Alright, it will always be there. As I said, it's imaginary, so it's not really part of the graph. And what this imaginary line is called it's called your axis of symmetry. And on each of these graphs, I'm going to be pointing it out to you. I'm going to be pointing out what your axis of symmetry is, and I'm going to tell you what the value of your axis of symmetry is. And your axis of symmetry in this case holds a value of 0. It's x equals 0. Your axis of symmetry will always be the x value of your vertex. What is the x value of my vertex? 0. So it's x equals 0. The last thing I want you to notice is that this U-shape, this parabola, opens up. So since it opens up, it's going to go forever and ever in the positive direction, but not in the negative. It gets to a lowest point, and the lowest point here occurs right here. So since we have a lowest point, we're going to have a minimum value, which will be at our vertex. So our vertex will always be the minimum value, or if the parabola opens down, which we'll see next, the vertex will be a maximum value. Alright, so why did my parabola open up? We'll talk about that in the next video.